So yesterday we left off on this bottom right corner of our front page of our notes. It is a two-sided page of notes. The second page, the back side, is for next week, and we're completing the front side right now. We're going to continue with more practice on solving two-step equations. So if we take a look at this first one right here, once again, an equation is like a balanced scale, right? So the equal sign is what separates the left side from the right side. And the goal of solving any equation is to do what? What's the goal of solving any equation?
To get the variable by itself.
Get the variable by itself, get the x by itself, or whatever letter we have, bless you, get that variable by itself. So you see the x is on the left side of the equal sign. It's not by itself. It has a 2 in front and a plus 3 behind it. So which one do I get rid of first? The 3. Remember, x is what's important. You want x by itself. 2 is with the x. It's kind of important. This 3 is all by itself. Get rid of that guy first, right? So let's get rid of that plus 3 by doing the opposite, subtracting 3, right? And if you do take away 3 from the left side, it gets lighter. It's off balance until you take away 3 from the other side as well. Then it gets back to balanced, right? So we really have 3 minus 3, which is nothing. So you could just scratch it out. The 2x comes down. The equal sign also comes down. And you have 5 take away 3, which is 2. Now at this point, you got to really understand what's going on here. Like, I need to get rid of this 2, but I don't take away 2. What do I actually do? Divide by 2, right? You got to understand that it's saying 2 times x, right? There's a multiplication that it's invisible, but 2 times x. So the way to get rid of that multiplication of 2 is to divide by 2. And when you do to one side, you do to the other side. And of course, 2 divided by 2 is 1. You could write 1x, but you don't have to write the 1. Actually, I never write the 1. So that's just x equals, and 2 divided by 2 is 1. So there's your answer, x equals 1. If you wanted to double check it, all you got to do is get your answer, x equals 1, and actually plug it right in there. And what we would have is 2 times 1, which is 2, plus 3. That really does give us the 5. That's what we call double checking, right? Anyways, moving on. Number 2, same deal. What do I get rid of first?
The 4.
How do I get rid of that? Plus 4. Minus 4. What do I do to one side? Must do to the other. What do I have left? On the left side, what do I have left? Negative 3x. Bring down the equal. 16 take away 4? 12. Cool. So what we have here is negative 3 times x equals 12. Now at this point, you might already be able to solve it in your head. Like a negative 3 times a negative 4 will give you a positive 12. But I don't want you to do it in your head. I want you to actually continue and do the inverse operations to isolate that variable to get x by itself. So the way to get rid of that multiplication of negative 3 is to divide by negative 3. And when you do to one side, you do to the other side. Here we go. X equals 12 divided by negative 3. That is a negative 4. Again, if you're not too great at multiplying or dividing, calculator is always your friend. Okay. On the quiz or test, you can't use your cell phones as calculators. All right. So just keep that in mind. You actually need a calculator, and I do have some at my desk. Number 3.
Use the chroma calculator.
I need to get x by itself. What do I do? Plus 4 to get rid of that minus 4. What I do to one side, I do to the other side. What do I have left?
Negative 8. Negative 2.
Rewriting the whole thing. Negative 2x. Bring down the equal sign. Equals. And on the right side, I have what? Negative 8. Again, if you owe 12 and you have 4, you're going to still owe 8. Now that's really saying negative 2 times x equals negative 8. So I need to get rid of the multiplication of negative 2. I want to get rid of, by dividing. That's exactly right. Divide by negative 2. And it has to be the exact value, right? If it's a negative 2, divide by negative 2. If it's a positive 2, divide by a positive 2. So in this case, we're dividing both sides by negative 2. This cancels out. I have a 1x. I'm just going to write x equals a negative divided by a negative is a positive 4. X equals 4. Once again, if you wanted to, you could take that 4, plug it right here. It's a regular 4 right here. Negative 2 times a regular 4, that's a negative 8. That's like saying that you owe $8 and you owe $4 more. You're going to owe a total of $12. That's how you double check your answers and make sure you're doing it right. Next one, what do I do? Minus 4 to get rid of that plus 4. What I do to one side, do to the other. I rewrite it. What do I have left?
Negative 2x equals 8.
Negative 2x, the equal sign, and 4 take away 4?
Oh no, minus 0.
0. Interesting. So I still need to continue getting x by itself. In the front, I have a negative 2 times x. I don't want a negative 2 times x. I want to get rid of that multiplication of negative 2. So I'm going to divide by negative 2 and divide by negative 2. Now, at this point, x equals, if you get your calculator and do 0 divided by negative 2 on the calculator,
0.
It's going to be 0. And that makes total sense because 0, let me write it over here on the side, 0 divided by any number is 0. What does that mean? There's nothing to start with, and you're going to divide it by 2 or by 3 or by 100. If you have nothing to start with, it's still going to be nothing. Make sense? So 0 divided by any number is still 0. So the answer is actually x equals 0. Okay? If you plug that back in, plug in a 0 right here, negative 2 times 0 is 0. 0 plus 4 really is 4. You just double checked it. It's not that it has no value. It actually has the value of 0. 0 is a number. It's a whole number, right? So x equals 0. You can't say no solution. That's not the case here, right? It's actually x equals 0. Number 5, we get to some fractions. How many people look at that and they're like, man, that's confusing? Anybody? Anybody think that's confusing? Yeah, okay, what's confusing about it? Well, that it's a fraction, huh? Would it be confusing if you didn't have this? What if it was just a c minus 5 equals 6? Is that confusing? Heck no, that's easy, right? All you got to do is add 5 and you're done. But it doesn't say c minus 5. What does it really say? It says c minus 5 divided by 4, because that's what a fraction is. It's a division problem. That really says c minus 5 divided by 4. If you don't want something, all you got to do is do the opposite to get rid of it, right? So if you don't want the divided by 4, what do you have to do? What's the opposite of divided by 4? Multiply by 4, right? So we're going to put a multiplication dot. I see some students still using x's from middle school. Don't do that, right? Put a multiplication dot and put the 4 up on top on the numerator, because that's when you truly have a 4 up on top divided by a 4 on the bottom, and we know that 4 divided by 4 is 1. It'll cancel out. But before doing that, if you multiplied by 4 on the left side, you have to multiply by 4 on the right side to keep the balance. Anyway, now 4 divided by 4 is 1. What's left on the left side? C minus 5. Bring down the equal sign. 6 times 4 is, use a calculator if you don't know, 24. Final step of getting c by itself is to add 5 and add 5, and you will get c equals 29. C equals 29. Now let's say you're confused about that. You're like, I'm not too sure. I probably made a mistake. That doesn't sound right. C equals 29. Well, what if you did plug in a 29 right here? What's 29 take away 5? 24. And what's 24 up on top divided by 4 on the bottom? 6. So you know you did it right. All you got to do is plug it back in and double check, right? So technically, there are no excuses. Everybody should get a 100% on the next quiz of solving simple equations, because you could always plug in your answer to double check and see if you got it right. Last question, number 6, has a fraction. What do I do here? Some students get confused. Okay, so keep in mind, I heard somebody say multiply by 3. You could, but that's kind of, it's rough. I always say what's important, the variable, right? In this case, g. You want g by itself. You want to get rid of everything, but g is what's important. This guy is with g, he's kind of important. This guy is the loner. You don't care about this guy, get rid of this guy first. Always get rid of the constant, the number that's all by itself without the variable. So let's get rid of that plus 6 first. It just makes things easier. Subtract 6. I end up with 2/3 g equaling 10 take away 6 is 4. Yay? Okay. So at this point, you want to get rid of the divided by 3. You don't want a fraction. It'd be nice if it just said 2g equals 4, right? So if you want to get rid of the divided by, if I want to get rid of that divided by g, all I have to do is what? Multiply. What did I say? Divided by g? Divided by 3. You're going to have to multiply by 3. I'm losing my mind. Anyways, what you do to one side, you must do to the other. 3 divided by 3 really does cancel out. What do we have left? A nice, beautiful 2 and a g equals 4 times 3 is 12. So what do I have left? I have a 2 times g equals 12. To get rid of that multiplication of 2, what do? Divide by 2. What I do to one side, I do to the other side. G equals 6. I think that's the most clear way of solving this problem. Now, let's say that you really wanted to get rid of the fraction first. I don't recommend that. Why is that? Because No, it's not that it's hard. It's just that it makes the numbers bigger, because remember, you could do whatever you want to an equation as long as you do it to both sides of the equation. So like, let's say you did want to start, let me rewrite the whole thing here. Let's say we had a 2/3 g plus 6 equals 10. Let's say you did want to get rid of the fraction first by multiplying by 3. What you would have to do is multiply everything by 3, both sides, the entire left side and the entire right side by 3, okay? Because you didn't get rid of the 6. So that's why you have to multiply everything by 3. So then, yeah, you'd be able to distribute there, but then you'd end up with the 18. Like right here, yes, the 3's cancel, and you'd end up with a 2g. I don't recommend copying this down, guys. I'm just going to show you that you could do it, but it's not the best option, because over here you end up with the 18 equaling 30. So you see the numbers got bigger by getting rid of that fraction first, as opposed to getting rid of the number 6 first, and you still got nice numbers, and then you could get rid of the fraction. So it's a lot easier the first method we worked through. There's many roads to the same place though. So if I kept going, minus 18, that would give me 2g equals 12, and you would divide both sides by 2, you get the same answer, g equals 6, right? But I prefer this original method over here. It stays true with what I always said, that you want to get g by itself. This is with g, it's kind of important. This guy's the loner, get rid of that guy first. The one that's a constant without a variable, get rid of that guy first. Go this route, it's a lot easier. All right, so this was just the end of our front side of our notes. The back side, we're gonna wait till next week. So don't lose it, we're gonna wait till next week. Right now, we're looking at the worksheets. This is what we did yesterday, 2.2. These were all one-step equations, right? One-step equations. Like, how did I get rid of that 8 to get the j by itself? Divided by 8. How did I get rid of the, let's say, that fraction? How did I get rid of that fraction? Multiply both sides by 9. So I guess you guys get the idea. These are all one-step equations. However, we did have some word problems down here. And I'll tell you what, you could skip number 21, but the other ones, let's do, right? So for example, number 19, it says -9 times a number equals -117. So that'd be -9 times a number, you could put n, you could put x, you could put whatever variable you want, equals -117, and then you solve it. Again, that's a one-step equation right there. Okay, all you got to do is what? How do you solve that equation? Divide both sides by -9, and that will be your answer. I don't know. We are going to have bigger numbers on the worksheet, so you could use a calculator right there. What is 117 divided by 9? 13 it is. So n equals +13 in this case, all right? Again, we're going to skip 21 because you technically have a proportion that we'll later learn how to do in a future section, which will be a lot easier. This one, even though it's a proportion, it could work out nicely. Let me show you. -1/8, that's -1/8 of a number. So you could put x, you could put n, you could put whatever you want. So there's -1/8 of a number is -3/4, okay, is -3/4. So what would you do here to solve for x?
Divide by 8.
Okay, so you don't want this divided by 8, right?
Well, times.
So times 8, that's right. We're going to go times 8 right here. And what you do to one side, you have to do to the other, times 8 over here. So the 8 divided by 8 does cancel out. I do have a -1x equaling, and over here you could say 3 times 8 or -3 times 8 is -24, and then divide it by 4, that'll give you a -6, right? Or you could also say 8 on top divided by 4 on the bottom. 8 divided by 4 is 2. So what I really have is a -3 times 2, which will also give us a -6. And remember, you want x by itself. You don't want a -1 that's being multiplied in front of the x. So you could just change the signs or multiply both sides by -1 or divide both sides by -1. But the bottom line is x equals +6. So 21, it doesn't work out that great. So we're just going to skip it for now. 22, we could do that probably with the calculator would be best. You have 2.7 times a number equals 8.37. How do you get rid of the multiplication of 2.7 right in front of x? Divide by 2.7. What you do to one side, do to the other side. Divide by 2.7. So again, calculators are definitely friendly. X equals, I need a calculator. What's 8.37? 3.1? So 3.1 is the answer. Why did I put 3.7? Wait, sorry, 3.1. Sorry, there you go. Not that one. This one. So this is the worksheet that we're doing today for the rest of the class. You see, I've been teaching it, these two-step equations. You guys need to own it, right? There is some word problems. 1, 2, 3, 4. There are some equations down here. 2, even 3-step equations. Why do I say 3? Well, check out like number 17, for example. What do I do first to get q by itself on the left side of the equal sign? Add 7 first. So we're going to go plus 7 here, plus 7 over here. So that's one step right there. What do I have left? I have a 3/4 q equals 8 plus 7 is 15. And yeah, to get rid of the divided by 4, I'm going to have to multiply by 4. So I'm going to put times 4 here, times 4 over there. That's our second step, right? So the 4's cancel out. What do I have left? I have 3q equaling 15 times 4. What's 15 times 4? That is 60. You could use a calculator, of course. And now we're at our final step here. Get rid of the multiplication of 3 in front of the q. You're going to divide by 3, and you'll get your final answer. Q equals 20. Of course, the calculator is your friend. This reminds me of a joke. Hey guys, what's 5q plus 5q?
10Q.
You're welcome.
Oh,
Did-
10Q.
No? Okay, sorry. That's not funny at all. 5q, 10q, you're welcome. All right, okay. I'm sorry. Ladies and gentlemen, I do want to talk about consecutive integers. Consecutive integers. So like number 25, find two consecutive integers whose sum is 35. What does it mean to be consecutive integers?
Consistent.
Like, okay, when you go to, let's say you're sick, you go to the doctor, they give you some medicine, and on the instructions it says, take for 5 consecutive days. What does that mean?
Come sick and like.
Back to back, right? You got to do 5 days of that medication in a row. You can't like take one on Monday and then skip Tuesday, Wednesday, and then take another on, Thursday. Like you can't do that, right? So you got to do consecutive or right next to each other, right? So if I say, here's this medicine, take it for 5 consecutive days in a row, it has to be 5 days in a row, right? Right here, find 2 consecutive integers. Well, what the heck are integers? They're just numbers, nice numbers, right? Yeah, they could be negative numbers, they could be positive numbers, but they're nice. There's no decimals, no fractions. So 2 consecutive integers. Give me two numbers that are consecutive.
5.
5 and 6,
6.
right? Or negative 23 and negative 22. Those are right next to each other, right? Consecutive means right one after the other. So find 2 consecutive integers whose sum is 35. Now, we could all answer this with our minds, right? Like guessing, 18 or 17 plus 18 gives me 35, right? We could do that with our mind, but the skill that I want you to acquire is to create an equation. Now, bless you, let's say any number. You don't know what it is, so you could label that number x, right? Okay. Now, it doesn't matter if x is 13 or 17 or 55. The next number has to be just 1 unit more than that one, right? So x is your first number, and it says you want to sum, so that means add it with another consecutive number. Right after x, it would be x plus 1.
Oh.
Does that make sense? Okay, I know it's kind of weird, but whatever x is, if it's 5, then this one has to be 6 in order for them to be consecutive. If this is 17, this one has to be 18 in order for it to be consecutive, right? And we know that the sum, the addition of this number with the very next number is 35, So the reason why this is a great problem is because it kind of opens the door to the next type of equations that we're going to be solving, the ones that require simplification. You see, on the left side, you could simplify. There's 2 x's. And if you did go x plus x, what is x plus x? It's 2x. And of course, what would we have left? You have the minus or the plus 1, bring it down. The equal sign, bring it down. The 35, bring it down. Now we have created a simplified equation. And now we could solve this. How do you solve this? You subtract 1. You're going to end up with 2x equaling 34. And for my final step, what do I do? Divide by 2, and I will get x equals 17. Now, we got to understand that x is just this first number. So what would the next number be? 17 plus 1 is what? 18. So the two consecutive numbers are 17 and 18. I know that sounds like a lot of work, 17 and 18. Those are the consecutive numbers whose sum is 35. If you add 17 plus 18, it gives you 35. But again, yes, we could have done this with our minds and thought, okay, just any two numbers that are right next to each other that if I add together give me 35, and you could just start guessing, oh, 20 and 21. No, that gives me 41. That doesn't give me 35. So you could have guessed and checked, but the skill that I would like you to acquire is to start thinking of how to create an equation. You don't know that first integer, so we put x, and we know that the next integer, if it's consecutive, is going to be that same value plus 1. So if it's a 17, then this one's going to be a 17 plus 1, which is an 18. And we're going to find the sum of these two numbers that give us 35. And if you create this equation and you simplify x plus x is 2x, and then solve, you'll get your answer x equals 17. So you know your first number, add 1 to get your second number, and that's how you do it. All right.